Hello, everybody. Welcome back to our webinar series on phytosanitary issues organized by the European Cooperative Programme for Plant Genetic Resources on behalf of our partners in the Generous Bridge project, U4Gen and ERFP. The webinars are in preparation for an upcoming workshop on phytosanitary barriers for genetic resources and provide relevant background on existing regulations and initiatives on plant and animal health. Again, a few practical things. Today's webinar will again be recorded and made available on the workshop website. The presentation will be around 15 to 20 minutes with plenty of time for some questions after. You can write your questions into the chat box or raise your hand if you wish to speak after the talk. Finally, if you haven't yet, you can register for the final webinar next Monday using the link that I'll be posting in the chat in a couple of seconds. So we started our webinar series on Tuesday with a presentation from Yannis Karamitzius from the European Commission DG Sante, who gave a good introduction to the EU plant health regulations. I hope you enjoyed the CGIAR webinar on Wednesday, where a global panel discussed a variety of issues related to germplasm health in preventing transboundary spread of pests and pathogens. Today we will hear from one of the organizers of Wednesday's webinar, Lava Kumar, who joins us from IITA in Ibadan, Nigeria. Lava Kumar is the head of germplasm health, virology and diagnostics at IITA since 2007. He is also the coordinator of the CG germplasm health component of the CGIAR Genebanks platform. He holds a PhD degree in virology and has 25 years of plant health research experience, all of it in CGIAR. Together with his colleagues from other CGIAR Genebanks, he has been instrumental in developing the GreenPass initiative, which he will tell us more about today. Over to you, Lava.
Thank you. Thanks a lot for this brief introduction. And also I would like to thank at the outset the organizers for giving me an opportunity to share a few, some of our experiences with regard to germplasm distribution from CGIAR Genebanks, and as well as the GreenPass concept. At the outset, I would like to mention that we are not a regulatory agency. We are more like the beneficiaries or users of the regulatory system that exists, enabling movement of plant and planting materials. So the presentation, I have kind of 5 elements. Yeah, I have not broken them into kind of sections, but these are the key topics that I'll be touching. Briefly about who we are, because it's very important to mention what is the CG system is to give a context of why we are distributing germplasm all over the world. A bit about the gene banks and germplasm health, phytosanitary requirements within our programs, and how do we do germplasm exchange, the kind of decisions, the kind of challenges that led us to propose this GreenPass concept, which is still very much work in progress. And lastly, the conclusions. So CGIAR, previously it has a expanded abbreviated version, but since 10 years now, CGIAR is just CGIAR. Basically, it's a global organization for international agriculture development. It encompasses 15 centers spread all around the world, touching various aspects of agriculture policy and environmental protection. There are 11 of these centers directly work on crop improvement. And there are institutions which are specifically focused on policy like IFPRI and UMI. And then there are a center which is focusing on animal genetic diversity, which is ILRI, which is headquartered in Ethiopia. And there are 2 centers on forest trees, ICRAF and C4. There is also a center focused on fish. But my topic, the germplasm health, mainly deals with the plant germplasm distribution. So we only deal with 11 centers. I am based in IITA headquarters, which is located in Ibadan, Nigeria. The CGIAR primarily works on a number of aspects, from breeding to biotechnology, natural resource management, the policy, gender issues and all. But All of it contributes to the 5 impact areas. The first one is climate adaptation and mitigation. Whatever we do, we need to think about how our work contributes to these 5 impact areas. The second aspect is gender equality, youth, and social equity. Um, the issues around nutrition, health, and food security, poverty reduction and livelihoods through employment generation from agriculture and related activities. And lastly, environmental health and biodiversity protection. The gene banks and the breeding programs, the work they perform cut across all these 5 impact areas. Biodiversity protection is particularly important when gene bank, which hosts more than 770,000 germplasm accessions. As I mentioned, the system has 15 centers. There, it works with almost all partners around the world, including many organizations within EU, and the European Union itself is a major donor for the CGIAR activities. We have direct activities spread in 108 countries, and the system was established in 1971, but some of the centers like IITA were established even before CG was formed. So IIT was established in 67, 2 years before ERI. So we are 50 years as a CG this year, but some centers are celebrating 55 years and 60 years. So gene banks is one of the main assets of the CGIAR. It has contributed to both production of important crop diversity, essential for food security, as well as uh, for livestock, feeding livestock. They also helped as a kind of a network and custodian for conserving global germplasm on behalf of United Nations and FAO. So gene banks is a kind of a primary asset, and then linked to that is breeding programs. We have gene banks spread almost in 34 countries, with their headquarters is located, or the main gene banks located in the 11 headquarters of each of the 11 centers. Whereas the breeding programs are far more decentralized, also spread in more than 30 countries. And then the delivery of the products from both gene banks and breeding programs stretches far beyond the 35, 40 countries where these programs actually operate. The gene banks of CGIAR mainly focus on the crops that are essential for food security and biodiversity management, once again in the context of livestock and the trees, economically important trees. So there's a long list of crops, but the most important aspect is collectively the 11 centers conserve more than 770,000 germplasm. 93% of it are the species which are conserved as a orthodox material, like a typical botanic seed. 3.3% as vegetatively propagated crops, like in vitro clonal crops are in the field gene banks, and 3.7% of this collection is tree germplasm. CG also conserve material for safety duplication in the Svalbard Nordic Gene Bank. One of the key aspects of the gene banks as well as breeding programs is the international distribution of germplasm, both for our own programs as well as for partners who can request. Anybody can request germplasm from CGS centers, and all the information about the germplasm that is available are hosted on the GenBank websites. And there is online request form through which anybody can submit a request, and the centers will distribute a small quantity, not too much, quite often in the form of 5 grams to 50 grams, depending on the kind of germplasm and the type of material. If it is in vitro, then it up to five tissue culture plantlets. So it all depends. But the germplasm that is exported is of a small quantity. So from the annual statistics, you can see that the number of samples that are distributed for our own program, which is indicated in the green bars, and then those requested by other partners who are not associated with the CG programs. So these numbers often varies, but quite often it's quite substantial, often reaching minimum 60,000 per year, and sometimes going up to 100,000. And the accession distributed is also very important. The samples is different and the accession is different. The more number of vaccinations means the more diversity we are distributing across borders. This is the data for 2019. As you could see from the 11 gene banks, almost the bulk of the material, nearly 80%, is going to the countries, developing countries located in Africa, Americas, and Asia. That's very small. About 20% is going to the advanced countries, Europe, Australia, and US. And much of the material that is going to advanced countries are mainly for research, quite often for genomics work, where rather than for germplasm for planting. Another important aspect to remember is globally, CG centers distribute almost 80% of the germplasm under what we call as a plant treaty, international treaty on plant genetic resources for food and agriculture. So the highest share, nearly 60% of it, comes from the breeding programs and about 30% from the gene banks. And this map basically shows the countries reached in 2019. So if I plot the material movement between centers to the countries that were requested only for gene banks, not accounting for breeding programs, it looks like a kind of a airline map. It's a very heavy traffic moving across within the continents and across the continents. Every year we reach about 90 to 100 countries. Sometimes it goes beyond, with 60 to 100,000 samples representing at least 20,000 actions, sometimes up to 40,000. We invest nearly we 10 to 12 million US dollars annually for generating clean germplasm, including health testing. We perform almost collectively 1 million diagnostic tests. That's a very conservative as an average to ensure that the material that is moving out from centers are tested and are in compliance with the importing country requirements. Why this testing is so important for CG centers, why we don't rely on quarantine programs. This is for a main reason that the number of countries that we are doing business or sharing material are located in the developing countries. This is a study done by Erla et al. Published in Nature in 2016, one of the Nature publications, exposing the deficiencies in phytosanitary capacity, perform proactive or reactive capacities. So as you can see, almost all the developing countries are in a kind of red and orange shade. That means the capacity is very weak. So what happens if there is any mistake, if but germplasm is not adequately tested, and if the material is sent to the partners, it's very likely that the material that is received will be sent for further propagation without further testing. And if that material happen to have any pest or pathogen, it will get propagated during the seed multiplication stage and may cause local outbreak and then may spread beyond. And there are numerous examples. Okay, these examples, of course, we don't have exact knowledge on the path of entry, but these are some of the key major outbreaks that were recognized in the last 10-15 years caused by introduced pathogens. What we don't know is how they have entered into these countries. Is it through seed or other form of trade? In some cases, like banana bunch of Physarum TR4 definitely came through seed, but whether it's a by whom and when is something nobody knows. Okay, so there are numerous diseases like maize nettle necrosis in East Asia. From sequence analysis of the viruses, we could estimate that it probably have moved from East Asia. Wheat blast, it has moved from Latin America to Bangladesh, and most recently in Zambia. So there are numerous. All of this we recognize because they have caused big impacts, and that's why CGs have the germplasm health units, which pretty much act like a kind of internal quarantine with a primary mission to safeguard against introduction of exotic pests and new virulent forms of existing pests, help CG scientists and partners to safely distribute plant germplasm, and ensure, this is the most important aspect, centers compliance to domestic and international procedures. Since we operate in different countries, it is mandatory for international organizations to comply with the national regulations. Otherwise, for violating, we could face sanctions. if the CG centers lose their ability to distribute germplasm, then our relevance as international centers diminishes dramatically. So this activity is very, very important. The GHUs have full internal capacity, interdisciplinary capacity to develop diagnostics, to validate diagnostics, establish treatments for eliminating pests from both seed as well as clonal crops, and know-how on how to comply with the paperwork required for various phytosanitary organizations. We also participate together with the national programs on pest risk assessment. We also have a community of practice where we disseminate knowledge and technology to partners through workshops, seminars, webinars, etc. And we are very vigorous with capacity development activities, especially in developing countries. So in this map, basically this is the global CGIAR germplasm health network. We are located in different continents, and we work closely with a number of partners in each of these countries, and we have a a decent knowledge with regard to what is happening on ground, especially with pest outbreaks, etc., on the crops of relevance to CG centers, so that we can take appropriate actions in advance. So together with partners, we have a kind of a global network, which is informal, but pretty much very effective. And this is our key strength that is enabling GHUs from the last 50 years being a very active and I would say successful programs in averting spread of quarantine pests. We have almost negligible reports with regard to interception of economically important pests in our germplasms. So there are more details available in this publication, which was recently published in Plants. It's open access. You can, if anybody interested, please access that one. Now a bit more details, like why anybody should test, trust what CG is saying, that our germplasm is good. It is mainly for two reasons. Number one, we have internal policy that mandates that all the germplasm flow from collection to evaluation, seed increase, and distribution is strictly in accordance with the procedures established by germplasm health units, which are in alignment with the national and international procedures. So this is very dynamic, considering the constant changes that happens in the policy and regulatory environment regarding the phytosanitary issues. So this, what we call as a GHU zone, pretty much covers all germplasm flow. And it is also mandatory for any bioresource exchange only happens through GHU. So therefore GHU serve as a kind of a gateway. So there is no, that helps in terms of ensuring the quality and also traceability. So that is one very important check that gives confidence on what we are doing. And we also have these protocols which are in line with the important exporting country requirements, both with regard to the documentation, etc. And irrespective of what countries are seeking, we make sure that the material that is moving out or coming in strictly meets our own internal standards, especially with regard to the health status. We can't guarantee that germplasm is free from every pathogen or every microbe, but we can guarantee that the material will be free from the quarantine pests that about which we have knowledge. And this is all based on the various protocols that are out there. For example, GeneBank standards, although it is very thin with regard to the health, it provides a basic guidelines. We use all the ISPMs that were published by IPPC. We extract relevant information from that. And we also established what we call safe movement of guidelines for safe movement of germplasm. These were there for some of the key commodities which are frequently exchanged, and some of them are now being updated. So soon, I think by in 1 or 2 years, we'll have all updated guidelines available. So basically, we ensure very strict adherence to the phytosanitary standards that is necessary for moving material. Now to my last part, why we are seeking the GreenPass and how this idea came up. I mean, as many of you are aware, movement of germplasm is pretty much treated as a sovereign right by the countries. They dictate whether they would like to accept or reject material. So it is mandatory as an international center to adhere to these guidelines. So we have zero choice. But then there are a lot of issues with regard to the way these policies and regulations being adopted and implemented by the various national programs across the world. We have global agencies, policy making at the highest level, like IPPC, for phytosanitary issues. And then we also have regional agencies like EPO, Inter-African Phytosanitary Council, which dealing at the continental level. And then at the national level, National Plant Protection Organizations. Ultimately, it is NPPOs, which are the implementing agency for all these policies. And what matters is how they interpret and implement the procedures. Okay, this is where the maximum diversity comes despite harmonized procedures across the global level. And this causes a lot of challenges despite we adhering to the legal requirements when we are testing our germplasm and generating planting material for international distributions. Um, we also have this what we call decision matrix, which we base ultimately whether we approve a particular germplasm to be distributed or not. I would not go into details, but what is most important is we have now current knowledge to say that we can't safely say any germplasm is free from microbe. Uh, we only can safely say we can declare health status for the known pathogens. So we primarily focus on all the regulatory quarantine pests and also non-regulated quarantine pests. This is our key area to declare health status. Okay, and we have a complemented matrix, and we make our own decision. Even if countries willing to seek for planting, if material is not healthy, we decline to share material. So under these issues, the constant problems that we face is from the producer side. For example, from centers, we have variable demands for paper declarations, paperwork. The same healthy plant material requires different kinds of testings, so which puts additional burden with regard to the cost and the procedures that we need to have. And then these they change constantly, sometimes without prior notice in a very short time. And these requirements are ambiguous. For the same germplasm, we will have one rule last month and the rule will change next month. Although there is no hard evidence on paper that the rules have changed, it all depends on how the person sitting on the desk interprets. So all of that leads to delays in clearance. Sometimes we lose germplasm in transit and loss of crop season. And this happens very frequently. And then from NPPO side, sometimes we also have to understand their issues. In many countries, they don't have pest lists, especially for the crops that are moved. We are not only dealing with the crops which are commercially important, like rice, maize. We are dealing with the legumes. Some of them are orphan, and also wild species about which very little knowledge is available. So there is a kind of an ad hoc adaptation of pest lists, and then they ask for declarations, which are very difficult to comply with. And also doubts on health status, like phytosanitary certificates issued by some countries are not trusted readily. Um, so all of this contributes to delays. What is the way forward? So we started this uh, concept. Like, for example, I am an Indian citizen. I have an Indian passport. And I also, one of my friend works for United Nations. He's also Indian citizen, but he holds United Nations passport. And he can pass across borders without visa very easily compared to me. The only difference being that the vetting process, the trust that United Nations passport assures that, oh, he is working for UN and he is trustable, okay, even though they don't know the background. It is as simple as that. We learned a little bit about green passports. I will not go into details. The idea is CG germplasm, once we assure health status, and if we can get a kind of a UN status, okay, these health trusted, and it can readily move without too many additional barriers, then it makes a difference. The analogy that I would like to use is the TSA pre in US, like this is the queue for security check. Everybody had to go through the scanners, etc. Whereas those who are qualified under TSA pre, they just walk through. They are not, uh, sometimes they don't even X-ray. This is based on the pre-vetting process. So basically the GreenPass is a similar kind of procedure based on the fact that we convince the quarantine agencies that our material has been thoroughly tested in line with the requirements. probably sometimes much more than what they're seeking. There are a number of steps that, as a consequence of GreenPass, we can avoid. Since our material is already health tested and we already made a decision whether it can move or not, and we should be able to get phytosanitary certificate without too much of delays, and the material is been dispatched, and when it arrives in importing country, they can trust that, oh, this material is coming from GreenPass, and they don't have to once again put through the post-entry inspection unless it is really obligatory. That therefore the material release to the end user much faster, and it reduces the time and the delays, which is ultimately contributing to the loss of cropping season and valuable material. This is not a kind of a halo proposal. It is based on a strong science and the policy. There are already procedures, ISPMs, which makes a lot of provisions, and countries are used to this, especially with regard to the trade advantage. When countries see a benefit with trade, there are a lot of phytosanitary concessions given based on assurances that were provided after the pest risk assessment. So we have to perform some of these things before we actually get a kind of informal approval. So we have now currently working on this pest risk assessment for gene bank activities and germplasm flows, which has not been done. Most pest risk assessment are only done for the commercial established products or commercial traded products, not for the research material. Why it is important? Because these three ISPMs that are very relevant for germplasm distribution are criteria for pest categorization by the countries. The countries make a decision. Yesterday, in the last seminar, we have heard from the EU presenter how they classify whether a particular pest is important or not. So that is guided by this ISPM. ISPM 36 for plants for planting. This is mainly for clonally propagated crops. And ISPM 38, international movement of seeds. They all have talked about the material moving for research, but they still very much relying on pest risk assessment. They still seek information on pest risk. So that is lacking for a number of crops that are held in the gene bank. So, and also many of these phytosanitary agencies are unaware of the what process that goes through the gene bank. So therefore, it is important we need to have pest risk assessment for gene banks. That is something now we are developing as a standard protocol. So ultimately, when we achieve all of it, we propose it to IPPC to either for ISPM or some form as an international guidelines. So we have written one blog which is available. With regard to the engagement with the regulators, we have already started discussions, and we have received a lot of positive support both from IPPC and their key stakeholders on the need for GreenPass for the material movement from germplasm repositories, as well as material moving for research. So there is a lot of momentum going around, and we have made good progress. And hopefully in 1 or 2 years, we will have this system established. But we already have a good support. And then IPPC said, even before we get into the kind of global accord, they are willing to consider a kind of a GreenPass protocol. It is not called as a GreenPass standard, but as a protocol under which CGs can start moving material quicker. So with that, I conclude my talk, and I'll be happy to take any questions. Thank you very much.
Thank you very much, Lava, for this very interesting and engaging presentation. And we already have a couple of questions in our in line. And again, I would like to ask people to post their questions into the question box, or to raise their hands if they wish to talk directly. I will start with a question that Vincent Johnson posted. He wants to know how much it costs the CGIAR to maintain its gene banks per year, and where those funds come from, because as we know, funding is a big initiative, a big problem for many of these activities.
Yeah, that's a very good question, and it's very difficult to give a precise answer because these activities are spread in different programs. But as a consolidated budget for conservation, it exceeds, without phytosanitary health testing, it exceeds $12 million per year. Okay. This is mainly for conservation. And then there is a budget for use and utilization, which is different.
Do the gene banks generate any income to support their maintenance, or
No, they don't
distribute?
support. The funding mainly comes from the international donors. There are a number of donors which contribute to conserving germplasm in CG Genebanks, because CG Genebanks are global custodians, so there are a lot of commitments to conserve germplasm.
Okay.
But
Another
it's always
question
a challenge. Yeah, funding is always a
Yeah.
challenge.
Yes. Vincent also posted another question. He wanted to know whether the Global Crop Diversity Trust is involved at all in these gene banks platforms.
Oh yeah, in fact, Global Crop Diversity Trust is the one which is coordinating this gene bank platform, Crop Trust. Yeah, and they lead this program, and they also contribute funds through their endowment grant.
Mhm.
So they're also a kind of a donor plus implementer of gene bank platform.
Mhm. Jens Weibel is asking whether the GreenPass has been subjected to ISO certification, or whether that was considered.
Yeah, that's a good question. See, GreenPass ultimately is a kind of an accredited system. Once we have the protocol in place, we need to have a checklist with regard to whether the gene banks are complying with this uh, safe guideline checklist, and this will be audited by the national program. So it is not under ISO, but what we have within our system is what quality management system, QMS. This is our homegrown quality accreditation system, which is monitored by the Crop Trust. Some centers like SIP, CIAT, and CIMIT, they also have ISO for laboratory diagnostics, ISO 30725, I guess. This is because their national programs actually mandated, because we perform our own health testing as a supplement to quarantine agency. Some countries, they demand, okay, we only accept your results provided you are under ISO. So under that circumstances, um, these laboratories are under ISO guidelines. But ultimately, GreenPass is an quality accredited system. Yeah. We also follow ISTA guidelines where applicable, especially for orthodox seed crops.
Mhm. Thanks. Lorenzo Magioni is asking, how could regional networks or national gene banks possibly join the GreenPass system once it is in place?
Yeah, so that's a very good question. So once it is accepted by the intergovernmental body like IPPC as an acceptable system, and then now the gene banks, be it national or regional, then they have to follow the quality guidelines and get accredited by the accredited agency, and automatically they will be qualified. So this only happens after this protocol is approved, and then the approval process is basically we'll have a procedure and the compliance guidelines checklist and all. So that's why this is a fairly long process, and this process is not going to be managed by CG. It is to be managed by IPPC, because they are the ones who set the standards. We don't have any say in it. We can only pitch in the need for this, and they appoint a technical committee to draft ultimately this protocol as international standard. But as a protocol for CG centers, that is something we are already working. And those NPPOs which are accepting this protocol, we already have what we call national green pass, okay, where we are moving material much faster because some countries already accepted this kind of system.
Thank you. Vincent had a question following up on this question. He's working with a coconut germplasm, so he wanted to ask for some advice on how to deal with the challenges they face with vector-borne phytoplasms.
Yeah, phytoplasmas are now becoming a big problem in germplasm exchange. Previously, they were not given due consideration. Now, actually, we are even going back and checking all our germplasm or phytoplasmas. The main approach we are using for cleaning phytoplasmas is through tissue culture, and by growing them in media containing antibiotics to eliminate phytoplasmas. So which is not that easy for some crops. They don't regenerate well in tissue cultures. So we don't work on coconut, and therefore I don't have much knowledge. But it is a problem. Phytoplasmas is a problem for both oil palm and coconut, even in West Africa. We had some discussions and we provided some diagnostic support, but we haven't done much with regard to the phytosanitation. So therefore, I don't have much experience in dealing with phytoplasmas in coconut. But dealing with phytoplasmas in cassava and yam and some other crops, it is mainly through in vitro uh, elimination procedure, just by growing plants in the media containing antibiotics.
Thanks. Final question, perhaps, since we're already running over time, is a question about IPPC and its role in germplasm exchange. What do you know about that, Laura?
Yeah, so this whole discussion on GreenPass actually started because there are no specific guidelines from IPPC on how on germplasm. Basically, all IPPC procedures, ISPMs, were established to support World Trade Organization. Basically, trade facilitation is the main objective of all the international standards, ISPMs. So anything that is not of trade importance were not considered unless the member countries demand for it. So what happened was national programs, when it comes to the other material, they try to deduce from ISPMs and then they make their own ad hoc protocol. That's why we are getting a lot of variations across different countries, how they interpret ISPMs and apply it for germplasm movement. So there is no standard guidelines. This is the way one should follow. And that's why we have been asking for that kind of protocol. And the discussion we have so far indicates it has to come from two levels. Number one, the first level is from FAO, who need to set standards for germplasm. And the second is from IPPC and member countries with regard to how to address, based on the standards, what are the basic requirements, what is the minimum phytosanitary framework that should be there. Then it forms the guidelines for NPPOs. Right now, it is very open-ended approach. Like EPO, for example. I mean, in the interest of time, let me not give examples. Yeah.
Well, I think we will have a good time during our workshop to discuss this in more detail.
Yeah.
There's like two more short questions, hopefully. So Matthew Ordich, he's working with vegetatively propagated crops, and he would like to know how to envision how this GreenPass system would work for these kind of crops.
Yeah. See, vegetative crops actually are more amenable for GreenPass because our system here is we establish pest-free stock. Let's take an example of either potato or cassava. We test all these germplasm for all known pathogens. In the past, it is using specific diagnostics or generic diagnostics. More recently, we have adopted high throughput sequencing. So it takes a bit longer time to establish what we call starter material. And once we have that stock, and then that material is used for building maintenance stocks and also stocks for distribution. So it is much more easier for GreenPass certification for this material compared to seed crops, because seed crops, they have less seed transmitted pathogens or seed borne pathogens, but often these material are multiplied in field sites. So after every harvest, we have to go through the testing process. Whereas for clonal crops, it's only at the beginning. So once we have the clean stocks established, then we pretty much don't have to worry about retesting as long as they are in that what we call biosecure facility where every stage is monitored and there is no without allowing any contamination, especially by viruses and viroids.
I guess that really works for best for tissue culture. What about for like field collections?
Yeah, field collection is a problem, right? Anything that is exposed in the area, in open area, is always a risk because we cannot guarantee especially for any cryptic viruses or cryptic pathogen that doesn't cause already symptoms. We can't maintain pest-free sites, especially if the size of the field is longer. So sometimes for essential material, we maintain greenhouses. For example, there are some wild germplasm. They don't establish well. I mean, if you conserve them long in cold storage, they don't regenerate. So they often have to be maintained simultaneously as live material. So there are big greenhouses for those purposes to prevent the reinfection. But if you have too many accessions and the size of the field is bigger, then it becomes impractical. So there are some challenges like this. Or we need to have pest-free sites. For example, in case of for maize multiplication, there are pest-free sites established to protect it from kernel bund, which is a problem for maize and wheat, mainly wheat distribution. So there are issues like this. Open fields always a risk. For example, tree germplasm of ICRAF and C4, not so much on C4, but mainly ICRAF. It's a big risk because they are all in situ and spread across different places because these trees don't establish in all environments. So they are the ones which are more vulnerable. We don't have ready solution yet, and we don't expect them to be under GreenPass.
Okay, that's thank you very much for your answers to all these very excellent questions. We will, as I said, make this video available on the website, and also the presentation. Lava, if it's okay, we can share this as well with the participants.
Sure.
And I would like to close and apologize for going a little bit over time, and invite you again to the last remaining webinar of this series on Monday, where we will hear about the EU regulations in place for animal genetic resources or animal gene banks. And then this will conclude our webinar series in preparation for this workshop. And I'm really looking forward to some very interesting discussions during this workshop. Thank you very much, Lava, and thanks to everybody.
Thank you very much, and my apologies because I consumed more time for my talk. So
that's okay. Yeah. It was very interesting.
Thank you.
Have a good day. Thank you very much.
Thank you.